All right. So let's get this started. So who am I and why I am here? So my name is Paulo, and I am one of the founders of Quirkbot, and been on the team from the beginning. And just a quick history on why this product came to be. A couple of years ago, me and a couple of friends, we started organizing technology workshops for kids. And we didn't really have any idea how to do that, and we just kind of started doing stuff. And along the way, we got to know Strawbees, which is this little thing here that we're going to talk about, which was not really a product yet. It was in very experimental phase, but it had a very amazing effect on the kids that we could pretty much just let them play with it, and they would just do stuff on their own, which was great for us because we were trying to run these events in the easiest way possible for everyone involved. And out of that, we started experimenting with other stuff. We were mixing up electronics and Arduinos and makey-makeys and a lot of other things. And we realized that there was a little bit of a problem with the tools that we were using. That they were good, they were great, but they required quite a lot of investment from the the facilitators, and we didn't have so much time for that, and they were very clunky, and we had to have batteries attached to them and stuff connected to a cable to the computer all the time, and it was not ideal. So out of that, after seeing how easy it was for the kids to engage with Strawbees, we started to think the same approach for electronics. How can we make electronics nicer to look at, easier to get into? And so the Quirkbot project came out of that. And my background is I'm a dropout graphic design student that also been programming since I can remember it. I've been very geek since I was a kid, and I was playing with computers a lot, and along that line, design was very interesting to me because it had this idea of expressing yourself, but it was also very grounded to a very systematic sort of industry, and it kind of fit both sides of my brain. But I realized a bit later that I'm much better in expressing myself with code than I am expressing myself with making images, and I kind of started going into the programming career a bit deeper. And my involvement in Quirkbot is that I kind of designed how you program this and how you go about thinking about programming in this environment. So when we get to see the interface and how you program it, you will you understand what I'm talking about. And so good, that was my quick introduction. And so let's talk about what you're looking at right now. So what's in the box? So this is the, let's say, the starter kit for the Quirkbot, and it has everything you need to start playing. And let's just understand what is in here. So okay, so first thing, Strawbees. It is this little package, and I encourage you to just open it and have a look at them and try to have some idea of what it does. And okay, and before I move on, I've been talking about myself, but I just want to hear quickly about you guys and why are you here today?
Oh, okay. Maybe I can start that so you guys can think a little bit. My name is Charlie. I'm the principal here, headmaster, and I want to learn about Quirkbots. And I think it looks like a really smart way to learn, to teach kids how to do this fun.
Mm.
Otherwise, I'm studying to be an engineer, mechanical. Not a dropout yet. Might become. Enough about me.
Don't take my advice.
My name is Björn. I've been a teacher for as long as I can remember. I study computer science and engineering in Linköping, and I do this as a summer job.
Yeah.
Yeah, well, I'm Julia, and it's the same. We just want to teach the kids, and it's a great opportunity to learn ourselves.
Mm.
Yeah, and I'm also going to be an engineer.
I'm Pontus, and I'm in the 11th grade in gymnasiet.
Yeah.
And yeah, I'm also eager to help kids learn how to make Quirkbots.
Yes.
My name is Anton, and I'm also in gymnasiet. And there I study kind of an architect angle on technique.
Mm.
Yeah, I'm here to be a teacher and also teach the kids about this.
My name is Quirkbot, and this is the first year I'm teaching here. And I'm here to teach the kids stuff about computers.
Nice.
My name is Simon. I'm a recent graduate from high school, and this last year, during my third year in high school, I took this programming course, Programming 1, and do you know about Makerspace? No, Me Hack It. It's a Finnish. Because we work with Arduinos.
Right.
And I'm also, this is my 4th year here, I believe, and also going to learn how to adapt this to the course. Not adapt, but just teach this to the kids.
Yeah.
So like everyone else.
Okay, cool. So most of you has been teaching with kids before, right? And programming, who can program? Who thinks they can program? Or, no, I mean, I like the first impression. Like, how do you feel about programming?
Yeah, I think it's really fun, and just very basic tools, you can go a long way.
Yeah.
Mm-hmm. Have you guys programmed, played around?
A little bit, but
Yeah?
I'm not very good at it.
Yeah, don't say that. Okay, cool, nice. So let's move on with the box. So we have strawbees that is in there, and then we have some straws. And these straws are not really that special. They are just regular drinking straws. These ones, we produce them, so we make them a little bit more rigid. You can take some out and have a feel for yourself. But this system works with any straw that has this size, which is kind of equivalent of what you find in like McDonald's and Subway, and it's also very easy to buy. So we do encourage to experiment with the material a lot. Like it's not only this that works, and this is part of the process as well. So let's take a look in the strawbees and how they behave with the straws. So the idea of strawbees is that we use straws as a building material. We use it, to connect straws together and build different structures. So if you look at strawbees, you will have variations of this shape that is like a little circle, and it can have 1, 3, 2, or 5 prongs. And the way they work in the most simple way is like this. You get a straw, and usually it's good to like just squeeze it a little bit, like just flatten it a bit, and then you squeeze in the strawberries, and then you get to something like this. And you could then get another one, and put in another straw. So now you have 2 little antennas or whatever. I mean, that's part of the mindset as well. Like, there is no right or wrong. Everything is possible. Just do it. You know, it's think less, build more. And then you can start doing some stuff with it. So for example, I could make a linkage out of this. And the way I would do that, I could get a 3rd strawbee, and I can just snap it on the circle, the hole of the first one, okay, like this. And I could then get it and attach to the second one, and now they are linked together, and you have some sort of joint. And you know, and now I've used the single strawbee, but if I had used double one or any other one, we start having some different properties in here. So now I have a double one attached to a single one, and you know, this could be some sort of lever for something else. And so that's the basics of the system, and you can push it in a lot of different directions. And to kind of just get the basic of it, in this booklet, if you go to this black page, we talk about a little bit of these basic connections. So we're gonna get a chance to get a feel for it. But just so you understand, like, this is kind of in the center of the whole system. And yeah, and these pieces, you know, we have a lot of them. So it's okay to bend them. It's okay to twist them around. They don't really break that easily. And even if they are a little bit bent, they're still gonna work the same. So don't be shy with the material, like really mess around with it. And if someone thinks that they really like the 5-1, but they wanna make this a little bit shorter, or they wanna take one piece out, let them cut it, because why not? You know, this is not a fixed system. Okay, good. Let's move on to what else is in the box. So when it comes to strawbees and straws, you know, once we take this out of the package, you can already see that it starts expanding in space and kind of making a mess, and putting it back together in the package might be what you want, or you might want to centralize all the strawbees and the straws in one place, and then you can have kids just take them from there. That's one idea. Depending on the case, it also might be educational to have the kids have their own amount and then put it back on again. It depends on the style of activities that you guys are going to come up with. But then we get to the juicy part of the Quirkbot, which is this little plastic box. And this box, it's nice to keep as the Quirkbot box. You know, later on, I encourage you guys to use the box to do something with it, because strawbees and cardboard also goes very well together. I can show you how to do it. And then I think eventually that's what you're gonna keep. And you know, usually you can have the kids get one box and then make sure they put everything back in the box or something like that. There's a sticker if you want to put it on the box or anywhere else. So let's go through what is inside the box. And this is all on the booklet, I guess. Yeah, but it's more fun to just go through it. So at the center of all this, let me just put this in here so I have we have the Quirkbot. So let's have a look at it. So the Quirkbot, it's kind of a little creature and a little thing that we like to look at it as something that has some life into it. So I think the first thing to notice is that the Quirkbot has a very similar shape to the Strawbees. If you get 5 Strawbees, you're going to see that it actually matches perfectly. And the idea behind that is that it's very easy to integrate the Quirkbot in your Strawbees structures. It has the same properties. You can attach it directly to straws, and you can use that to do stuff. And when you look at the Quirkbot, you usually look at it like this with this bigger metal piece, the USB connector on the bottom. And when you look at it like that, it reveals that it is kind of a little creature that has 2 eyes on the top here. And it has a right arm, and a left arm, a right leg, a left leg, and a horn. Okay, so this naming is quite important because that's how we refer to stuff. Unlike just talking of Arduino, we don't talk about pin numbers and slots. It's like connect something to the right arm, connect something to the left arm. And always from the Quirkbot's perspective. So the right arm is going to be at your left, and the left arm at your right when you're looking at it from the front, like this. Okay? So we have the arms, the legs, the horn, we have the eyes, and on the middle here, we have the heart, or the brain, or the nose, we decide. But that's where the magic, or not the magic, where the science happens. But that's the chip that controls everything on the board. And it is for a reason that this is not covered in anything, because we don't want to hide what is inside. The electronics are exposed. Even though this is very sturdy, you can throw the Quirkbot around and it handles the load. But yeah, just don't throw water over it, then it's not waterproof. On the back of the Quirkbot, we have a battery. So that's covered in black is a rechargeable battery that, well, we're going to see in a minute that when you plug this to the computer, you can both program it, but you can also charge it. And yeah, you can bring it to do other stuff with you. And you're going to notice that on the back, there is also this a bunch of holes. So this is a connector to put different backpacks on the Quirkbot. So we have this idea of backpacks as things that give the Quirkbot different superpowers. And you have one backpack in your kit right now, and it looks like this. Should be attached to like a little foam. You can just take it out.
Wow.
And this backpack is a motor backpack. So it lets the Quirkbot connect to motors. So it gives it the superpower to connect to motors. And you can just snap it like this. And there's only one way it goes. If it doesn't go, just flip it upside down. The arrow should be pointing to the horn, like that. And yeah, so once you have this backpack on, now the Quirkbot can connect to 2 motors at the same time. But we're going to see that. And if we flip it again, you're going to notice that in between the eyes of the Quirkbot, it has a little switch in the forehead. And just try moving the switch from left to right. It's a very tiny one. Yes? so everybody got it to be alive. Okay, so that's a living Quirkbot turned on, and we can see it by the lights.
What? Mine doesn't.
Okay,
Mine.
okay, so some of them come discharged from factory. It's a little
You
bit
got
of,
yours online. Oh, we have
yes,
excellent programmers over there.
I can give you one that is charged. But this actually is a good lesson, because always before doing workshops or activities, we need to make sure the Quirkbots are charged.
How do you charge them?
You charge them by plugging them into the computer or to like any other charger. I will show you how. But you can take this one for now. That I.
Do you have one more for Björn?
Oh yeah,
You
sure.
can share? I feel like I'm gonna break this stuff.
No. Don't
How
be
hard should
afraid.
you push this thing in? Do you push it really hard?
Yeah, it should just fit in.
It doesn't really-
What should be above?
Yeah.
No, it
Perfect.
Yeah.
Yeah, mine's heavy.
Whee! It's alive. Cool. So let's leave it there, alive, looking at us for a while. Another thing that we have in the box are these little pieces over here, the LEDs, and then we have these black ones, and these are light sensors. And we're gonna see how we use them, but I think one good tip is that, okay, now we've taken the backpack away, and we have this little piece of thing that, what do we do with this? So a very good thing to do is to just use it as a holder for the LEDs. So again, it depends on how you guys are gonna work with the material later on, but I usually just keep them attached like this. It's easier to work with. And another thing we have in the box is this over here. That is a servo motor. And well, let's open it up and see what's inside.
Oh, this is so tiny.
Yes, and there is a tiny screwdriver. Because anybody know what a servo motor is? Yes?
Excuse me? What?
A servo motor? Do you know what it is? You wanna?
It's an electrical motor, and it can be either 180 degree or continuous. So.
Right. So differently, when it's just a motor, usually it's just something that spins. A servo motor is kind of a smart motor. It actually has a tiny chip inside of it that lets us control it. And usually, and this one specifically is a motor that it can move to a certain position. So this is not a motor that spins around. This is a motor that you tell, go there, go here, go here, go here. So you can do really robot-y stuff. And the reason why you have this tiny screwdriver is because you have also these little shafts over here that you can, and I think the big one is the best one for now. So if you take one of it, and you can take a screw.
You never had kids choke on these, though, right? Not so far?
No, not so far. But yeah, we don't use it with like really tiny kids.
No.
Like that's a no.
I'm sure that's gonna be fine.
In that sense. And I mean, actually, this that we're gonna do right now usually is something that you just do once as well. You don't get the kids to do this all the time because it takes time. But what you do with this little shaft is that you just attach it to the top of the motor, like that. And we're gonna see later that you can adjust it. It actually matters what is the first position that you put it on. But for now, just put it there. And you can put the screw on top. And then with the tiny, tiny screwdriver, you just screw it in. So then you're going to end up having something like this.
May I spin it, or does that damage the motor?
It's not so good to spin it because it can be stuck in a gear inside, and you can break the gearbox without noticing it. And okay, we have 2 more things or 3 more things on the box that we can go quickly over them. And one of them is a micro USB cable. And this is just a normal micro USB cable. We have them in a lot. It's quite an industry standard, so which means we usually have a lot of them laying around. So yeah, if you need a replacement or just grab another one. But then there's something important that usually is a bit of a pain in the ass to deal with. That is, you have a cable that you got, I don't know, from a camera you had. And you plug it in, and you're going to see that it can charge the Quirkbot, but then you try to program it, and it just doesn't work. The thing is, some of these cables, especially the very cheap ones, they only have 2 wires inside, and it's like charging wires. So, and this one has 4 wires inside because it's a data cable as well. So just usually this is something to quickly test, like if you have a cable that doesn't work.
You have like a USB phone charger, that must be 4 cables, right? Because you can connect it to the computer as well.
Yeah,
and
I mean, you better look for it,
yeah.
because these phone chargers, you never know what you're getting if you're getting like a cheap one. So it's just, usually it's the first thing to test. It's not working with this cable, just try a different cable. And we have some alligator clips. Has anybody used alligator clips?
Yes.
Yes. Was that, how did you use them?
In physics class when we
Right. Yeah.
We connected the lamps and batteries.
Yeah, right. Good. Has anybody used a makey before, or knows what a makey is? Okay, then it's okay. Because you would recognize this. And then we have this on the bottom, and these 2 wires, they are just extensions for the servo cable. So if you want a really long servo cable, you could attach it to these wires that make it long, but we don't need to care about it right now. So let's get building. So I talked about these LEDs before, so let's just see how we can connect them to the Quirkbot. So one thing that you notice is that the Quirkbot is blinking these blue lights. And these are the eyes of the Quirkbot. And we can program them to do different stuff. And there's also 2 other LEDs on the board that you can control that are on the mouth. And if you want to see them, get the horn and just touch it on both sides. Yeah, so it's 2 things we're demonstrating here. One is, yeah, the LEDs from the mouth, but the other one is this sensor that is, we call it circuit touch. And it's a sensor that detects if electricity has moved from one pad, the one on the back, to the one on the front. So we're going to see that that's a very easy way that we can make things interactive with the Quirkbot and touch it to do something or something else. And we can also use the alligator clips to extend this into something bigger, and we can detect when things happen further away from the Quirkbot. So you know now that we can make the legs and the arms and the horn into sensors, but we can do other stuff with it too. And one of it is connect them to the LEDs. So if you pick the LED from your box, you're gonna see that it has a little bit of one leg that is a little bit longer than the other one, and that is because of polarity. LEDs usually they work in one direction. We're gonna see that this one is a little bit special though. But what you do with LED, you get it out and you can gently squeeze between the legs so they become a little bit more, you know, making like a pinch. And then what you do is you get the shorter leg of the LED, and the shorter leg should be facing the back of the Quirkbot, and the long leg should be on the front, and you just slide it into the arm.
Oh,
You're doing it on the
Alright.
horn, and that's with
Yeah.
the sensor now. Yeah? Everybody got it to light up? And then, you know, once that's...
Ja, den korta på baksidan bara. Oh my god. It looks like one of those at the airport waving in the...
Oh, yeah.
Come this way.
Why is your big?
Oh, I didn't know. I think it was touching. Oh,
Look at that,
touching.
yeah.
Oh, so you're unlocking. And okay, so I just noticed that yours fell down. So, okay, this we can see that is working, but you know, this is not really connected, right? So it could fall easily.
Mm-hmm.
So what you can do to hold that in place, you get a straw and you slide it in. So now it's secure by the straw. And this room is really bright, but usually this is already a quite cool like lightsaber thingy. It really lights up quite a lot.
Oh, yeah.
And maybe we can put the lights down. Well,
Oh,
Not that great.
yeah. Thanks God it's summer and the sun is shining. I'm not gonna complain about the light. Yeah, but we have a little lightsaber thingy. And as some of you noticed, if you touch the horn here, the LED is changing color. So this LED is slightly special because it's two LEDs in one. In one direction, the electricity flows, it lights in the color, and in the other direction, it lights in the other color. And right now, the Quirkbot is just programmed to, whenever you touch the horn, it's reversing the electricity and it's changing the color. And this is something we can program it to do automatically as well. Okay, so now we know how the LEDs work, and the light sensor we get in later. And the other thing that I want you to see now is the motor. So we have a little motor, and if you see on the back here, you have these two connectors with 3 pins on them, and the servo motor also has 3 inputs in the cable. So you can just slide it in, number 1 or number 2. The only thing you need to pay attention is that the black wire from the motor matches the black mark that you have on the backpack. And if it doesn't work, you just flip it. You know, so there is, it's not a problem to put the motor on the wrong position. It's not gonna harm it or anything. Yeah? So everybody got it to move?
yeah.
Good. Okay, so we can unplug it or turn it off for a second so we can actually deal with it when it's moving. And what I want to show you guys is, okay, so we have a motor that moves. What if I want to connect this motor to something else? Like, how is it that I make the interface of the motor to something else? And the way you do that is with the Strawbee. And you can pick your favorite Strawbee, whatever one. I like the double one. And there are two ways that you could connect a Strawbee to a servo motor. One of them, I think, is the one we show in the booklet. And okay, and all these things that I'm telling you guys is on the booklet as well, so you can refer to it later. But yeah, one way that you could attach the servo motor to a Strawbee would be unscrew it, and the Strawbee fits exactly in the base of the shaft, and then you screw it back. But that's not the only way. I like to not have them screwed because I can change easily the Strawbee. And usually what I do is I just get the Strawbee, I slide it into the hole like this, and now we get this a little bit weird structure. But what you do with this now is that if you get a straw, and if you align the Strawbee with the shaft of the motor, you can then get a straw, and you can use the straw to go over both the Strawbee and the motor at the same time. It takes a little bit of practice to get it right because it gets really tight. Yeah, but if you got it right, you'll see that it will really force the Strawbee to get aligned with the servo. Cool. So now things start to get more interesting because now this motor is doing something else than just spinning on its own, and very quickly you can make your first robot that is just waving around. So one thing that you can notice too is that this is moving. If I touch the horn, the same thing that was changing the color of the LED, I'm also gonna change the speed. And we could also switch to position number 1 and 2, and that's the inverted behavior. It's faster when I'm not touching it, and it's slower when I'm touching it. But what I have to think about this is that all of this that we're doing right now is the program that the Quirkbot comes built in with it. That's not going to be the program you're going to be using all the time. Obviously, when you're programming it, you're going to make your own behaviors and you're going to make it do whatever you want. But you can always come back to this code. It's very easy on the website. You just upload this again. So this can be also a good thing to do, like at the end or the beginning of an activity, that you just reset the Quirkbots too. And this also is very good to work with without programming because it already does some stuff, and you can.
You have some learning difficulties.
You're having a hard time to put it in.
Yes. I'm afraid of breaking.
Don't be afraid of breaking it. Yeah, so a good, always kind of hold it like this, squeezing it, because it makes it easier to slide in. So like this, and then you just push it down.
Then you can push it in a bit more.
But this is good that this happens now because it's something you can anticipate is going to happen in an activity as well. So you need to be ready to explain this. And if the kids are too young, you might want to do it before for them. Okay, good. So now that we have something that is moving, we're going to have a little challenge for you guys, which is to build a robot that we are going to make a little dance competition. And I can show you just one other tip that you can use to attach the motor to other stuff. That is to build a mount for the motor. This is also in the booklet, but it works like this. If you get two double Strawbees, and then two single ones, and what you do is to just align the double ones so it looks like it's just one, and then you get the single one and you slide it in, both of them, so you're gonna get the both connected to the single one, like this. Then you do the same on the other side. So you end up with a structure like this. And what you can do with this now is if you open up the double ones, you see we got a space in between them here. And I can get my motor, I can put the wire through that opening, and I can slide in the motor into it. Yeah, got it, you got it. And the idea behind doing this is that now I could connect this single one to something else. And I could, if I could make a hat now that is waving, I'm gonna make one. And again, it doesn't need to be one single one over here. You could have another single one, and then have a structure that is like this. You could make this into some sort of, you could have another one and have like 4 legs coming out of this. So what I want you guys to do, and we're gonna have 10 minutes to do that, is to just play around, have a feel for it, attach things together, and then in 10 minutes we're just gonna look at each other's robots.
We can call them robots even though.
Yes.
I will tell everyone.
All right.
But actually, you get to an interesting point, the telling part. The telling part is quite important. Like,
What I'm made.
yeah, how you talk about your robot.
It's a beauty. What are typical mistakes that the kids make? They're probably just like us.
Yeah, it's just like not understanding where can you plug things together, and I mean, I wouldn't call that mistakes. It's more like, you know, it's learning. It's a new platform, so you need to make sure to keep the first engagement high. So usually this thing that I'm doing here to do this is an activity that really works. Now I'm doing it a little bit more in depth because I'm showing you all the different parts, but I usually build a robot myself, that I bring it ready, and it just moves around, and I just ask the kids they can look at it if they want to get inspired, but then they have to build their own, and we do like or a dance competition or a little race, but it's always nice to have like a bit of direction, a bit of a goal, because then they don't get as frustrated. But I'll stop talking and just leave you guys breathing.
His legs are not moving or not working. Mine will be interesting. I don't know how I'm gonna make him. Oh, look at that! That's very clever.
Is it possible to make the engine go continuous, like 360?
No,
No.
We also have that engine, but that's like an add-on.
Right.
So we have other parts, but
Yeah.
these ones, no.
You can just plug in and 12 volts, or is it 6 or what is
No,
it?
so the Quirkbot operates in 3.5
3.5. Right.
voltage, so which is actually fairly common. These
Yeah, right.
things are usually 5 or 3.5. So yeah, I mean you can use off-the-shelf servos. Okay, so we're also using now the straws just as they are, which means that they're long, and then like if you try to make something stable, it can be harder. But obviously, you should make the straw as big as you want. I don't know if we have any scissors here, but you could just cut them, and yeah.
There might be some in the kitchen. Oh, you're right.
I mean, I think now it's okay to just get a feel for it, but
Yeah, I haven't figured out how mine is going to stand up.
I'm gonna have my crazy antenna here so I can observe better. And yeah, and this antenna here is based off a pyramid, which is a quite simple shape to build with Strawbees. That you can have a look in the booklet. And I just added the Quirkbot to it.
Oh, yeah.
Ja, det finns då.
Wait. This is...
Okay, have 2 minutes.
Ah! No. Right. Dance, robot.
Okay, so maybe we can just present what we have. And the way.
Mine isn't working. Doesn't do anything.
You're a bad dancer.
I think it's I think the battery's out.
No, fel.
All right, so.
You have a light on it.
I think that mine's dead too.
Yeah, they come with very little charge from factory. I can borrow you another one. So take this. It's an older version,
Look
but
at
I can.
Oh,
So yeah, as you're at it, tell us about your robot.
what have you made, Julia? Everything is
Alltså
good.
skaka rumpan.
It's a Quirkbot.
Yeah, maybe its thing is not to walk around.
It's a white man.
It's just dance.
I feel great about it.
Yeah, but you had some interesting thing that you had a pyramid on the base, so it's definitely solid.
Some compliment.
Yeah. Okay, so we have some sort of
Yeah, I think
hovering.
I guess
Oh, yeah.
a square pyramid in the bottom and 2 arms on the
Det är så
top.
här
Ah, yeah, we had a different pyramid that emerged. We're going for some.
Yeah, the thing was that we're going to build some kind of proof. I don't know
Oh.
actually what I was doing, but
Yeah.
that is something.
But you know, that's okay too, and I think it shows like part of the process that is, you know, how do you deal with planning your projects, and how do you deal with dealing with what is in front of you, what is happening, how do you deal with things not working the way you want them to work, which is something that can be explored as well, like getting actually different results than what you started thinking about is interesting too, and you actually learn to react to the situations that are in front of you, and you learn to adapt. So I think the key is how do you keep it not frustrating? How do you keep it so like, and you know, it's exactly talking about things like this. It's allowing the robot to reveal itself to you rather than you put your brain into it. Yeah, I have something that stands. And we also get a bit into the storytelling part, which usually helps a lot in the activities. That is to talk about what you built and give a name to it and tell a story behind it, because you know, robots are emotional things too. They are just extension of us, and there is no problem if they are a little bit weird and if they are indecisive. So encourage that sort of behavior as well, like to look at technology with a more emotional approach. Okay, good. So I think now there is some understanding of what is in the box and what you can do with like the basic without programming it or anything. And there's a lot to be explored in this, obviously, but we have a short schedule. So let's just move along because I want to show you guys a bit the programming part of this. You're not going to learn everything, but at least get a taste for it.
I really got a taste for it.
We're not going to talk about this, but what is this component?
Oh yeah, sure. I forgot to mention that. That's what we call electric strawbee.
All right.
And the ones, it doesn't come with a battery on them, but I have one here with. You just put like a watch battery into them. And what you can do with it is that you can just attach a LED directly to it. So it doesn't do, it has no programming approach to it. It just lights up. But then, and if we have time, I'll show you, we can use this in connection with the light sensor, and we can make this into different things. But it's, well, a lightsaber. Cool. Okay, so let's try to just organize a little bit so it don't get crazy. Because I'm going to need you guys to look at the computer right now. How does this feel so far?
Great.
Very fun. Yes.
Good.
I really want mine to dance.
All right, so everybody has their computer buddies. Yes. Yeah, and you can look at it. Mine as well. So okay, a good learning as well is that you need to always save up time for cleaning up afterwards, and actually it's a good idea to try to get the kids to be involved in that as well. So, you know, they can only finish when they give you back everything in one place or something like this.
This, no,
That's
this
not,
is it.
okay. Oh,
And I have one here.
yeah, I want to just charge the one.
This is the
I have
one.
one as well.
I think. No, maybe that's sharp.
I mean, that's charged.
That's the one that's charged. So you want the charged one or the?
Yeah,
Okay, the charged
actually, we're not gonna have
No, it
time
doesn't
for it
charge.
anyway. Let me just. Okay, so everybody with their computers.
Yes.
So what I want you to do is to open Google Chrome, which is the browser that we have to use in order to be able. We can use it, anyone, to program it, but in order to send the stuff to the Quirkbot, we need to use Google Chrome. And you're gonna go to code.quirkbot.com. And so when you go there, you see two things: join or log in. We all know how this works, right? You can either join, or if you already joined, you can log in. And the idea with logging in is that you can save your stuff. So I mean, shouldn't be any news for you guys. It's a service that you can have your account and you can have your stuff and you can share your stuff with other people. And you could also use it as an anonymous user, and you're going to be able to create programs, you're going to be able to upload programs. You are not just going to be able to save it. So then again, this is something that you need to think how you're going to deal with your students. Should they have their own account? If they're going to be recurrent, that's a good idea. Or should that be an account for the whole group, and then we can all log in with the same password? Or if they're going to have one contact with it, it might be okay to just use it anonymously and not save the progress. Logged in or not logged in, we can always access code from other people. So Quirkbot is public by default. So we have access to everybody's programs, and every program that you open, you can also copy it to yourself. We encourage that. So I'm just gonna log in to my account. And if you guys made an account, you should see something similar like this, your profile page, but it's not going to have anything into it. And so in my profile page, I have a list of everything I've done before. So I have a lot of programs. And but if I want to start one, I just click on this button, and that's how the Quirkbot interface looks like. So on the left, you have the nodes. So it's the things that you actually build your program with. And on the middle of the screen, you have the programming area. And on the top, you can basically upload the current program to the Quirkbot, and you can save your program. So for those who made an account, I could name this something, whatever, like my first robot. And the moment I press save for the first time, now this is on my profile, and it will actually be automatically saved every time something changes into it. So you actually just save a program once, and then everything you do just changes it. So it's just good to know. And also every program gets a URL that I can send to anyone, and then they can just access it. So if you want to do a programming exercise where you have a starting program and you want your students to just continue on top of it, you can just send the link to them. They just open it, and they can instead of save is going to be a button called clone, and then they're just going to copy that program to themselves. And on the left here, we have 3 sections for the nodes: inputs, brains, and output. So it's a nice way to think about programming, and to think about what the Quirkbot can do in terms of these 3 things. So the Quirkbot can receive inputs. It can interact with stuff from outside world. And right now, on this simple view, we have 2 of them exposed, and one of it is the circuit touch, is the one that we've been using before to detect when we touch it. Then we have another input that is called a light sensor that, well, detects light. The other thing the Quirkbot can do is to output stuff to the world. And right now we have 2 in here, is the LED and the motor. So the Quirkbot can output light and it can output movement. And then in between that, we have brains. So brains, they are not something that is coming from the outside. It's something that is happening inside the Quirkbot. And usually a program, it's either gonna have at least 2 of these. It's either gonna have an input and an output. So you could connect, like the one we had before, we have an input that is the touch, and this input is connected directly to an output. So I touch it, it lights. Usually that's the minimum you're gonna have. Or you're gonna have brains and an output, and that's what's happening with the eyes. So the brains of the Quirkbot are controlling the eyes. It doesn't require any input, and it's blinking the light. And sometimes, like this program right now, you have all of them involved. You have inputs that connect to outputs. You can have inputs that connect to brains, and that's how you build life into things. So how do we do this? So let's start from the beginning. So let's turn on a light on the Quirkbot. Okay, so first thing, everybody plugged in their Quirkbot, or maybe not everybody.
This computer thinks that our Quirkbot is a keyboard.
Then your computer is right, because the Quirkbot is a keyboard. You can just close that window. So not sure we're going to have time to get into that today, but you can use the Quirkbot to control your computer.
Oh, wow.
Because it can send in key presses. So you can, yeah. So, but that's good to know. If that appears, you just shut it down. And right, because this is the first time, if you just hit the upload button quickly, it's gonna say something like dependencies missing, and then you just okay that.
Install, you mean?
Yeah.
Yeah, and then it's gonna pop up a little window.
Yes.
That I don't need it because I already have it.
Little up.
Oh,
Yeah.
then you hang on a little bit.
Yeah.
Yeah, and if you press upload now,
No Quirkbots detected.
is your Quirkbot turned on? Yay, cool. Yeah, you can close that. That's the keyboard stuff that we talked about.
One quick question.
You can just close that window. Yeah.
Do you have, it looks very intuitive, but does it come in Swedish for the small kids?
Not yet.
Okay.
No. But that's something, I mean, it's built to be translated. We just don't have the translation in place. Just so you know what's happening with Quirkbot as an organization, I mean, now we are driving a lot of focus into content. So we are actually building, as we speak, a content platform that is going to have lots of lesson plans, like very structured and with a sequence to them. And this is going to be already in different languages, so you can access content. And also, yeah, the translated version of the interface matching that. So that's something that should come until the end of the year, but right now it's in English, which could be educational too for the small kids. Okay, so did everybody got to upload their code? So now your Quirkbot is not blinking anymore. It's just there with 2 lights on. So first thing, the red light. The red light, it shows even if I turn off the Quirkbot, the LED light, the red is still on. And it only stays on when I plug it in. And this is the battery indicator. So if this light is on, the Quirkbot is charging. And if I would leave it here for a while, and it could be like around half an hour for a full charge, this light would turn off. And when it turns off, it's because it's fully charged. Okay? But when I turn it on now, okay, every time I turn it on, the Quirkbot kind of says hello, and it does that by a blinking pattern, and then it starts the program. And now this program does nothing because there's nothing here. So we just uploaded an empty program to the Quirkbot. The only thing it does by default is to turn on this little light here, and that's just so you know the Quirkbot is on, because otherwise it would be very easy to just leave it on and not know that it's on. So that's what this light is doing. We can turn it off if we want to. So now we have an empty program on the Quirkbot. So let's program it to do something. So the first thing I want you guys to do is to bring a LED into the programming area. And one thing, who has worked with like Scratch or blocks before? Yeah? This is something different from that, but it's good that nobody been doing that, so you can get a fresh eyes into it. But we're gonna get to that. So I have this node in here, and it's a LED, and it has a yellow box, and this is the name of it. I could actually name it anything I want, my LED. And it has 2 inputs. One input that is called light. It's very hard to see here. One input that is called light, and is one input that is called place. So the light will control how much light am I going to send into that output, that LED. And that's a number that can go from 0 to 1. And 0 means no light, and 1 means all the light, like 100%. And the place tells us where that LED is going to be connected to. So as you've seen before, we have the eyes, we have the green LEDs for the mouth, and we have all the arms that we can also connect to different lights. So on this box over here, it's gonna give you all those options. So right now, let's just pick an eye, for example. So left eye. So what this program now is telling me is that I have LED connected to the left eye, and I am sending 100% of light to that LED. It's a very simple program, but it is a valid program. So if we hit upload, so it's generating the code, sending it to the Quirkbot. We got it. Yours is acting up a bit there. Did you get it, yours as well? So
Does mine still work, Anton, or is it thinking it's a keyboard? Oh, perfect.
Yeah, it was just yours that. Yeah. No, I think for some reason it didn't go. Just press upload again. Okay, can you maybe just start to turn off your Quirkbot? Yeah, and this is gonna fail, and you can just reload the page because your code is saved anyway. So that. Now turn this on. Turn it on again. That's very quick. Yeah. Okay. Try now. Yeah, that's a strange one. Plug it somewhere. Yes. Yeah, try it.
Jag vill bygga klart min.
Okay.
Ja, jag med.
Got it.
Jag hade nästan.
Yes. Sorry, I don't know what happened in there. It already got
It's good to
uploaded.
know the fail search.
Yes.
So we
so
can always
what-
just plug it in and out.
Yeah, so what we did when it failed, turn off the Quirkbot, reload the page, turn it on, try it again.
Isn't there because there's USB 2.0 and then there's 3.0 and the other one, there's different USBs?
Not in
I
the
know.
Mac like that.
Right.
It shouldn't really make a difference. Well, something happened there. Yeah, okay. So now we have a program that has one LED on the eye, which is not fun at all. It's just on. That's what I said, that usually you combine inputs and outputs or brains and outputs. Otherwise, it just do something and doesn't do anything else, right? So, well, let's do that then. So let's add some brains to this. So one thing that we usually use quite a lot is this structure called wave. So a wave is it's a number that is changing in time, and it's changing by going up and down, up and down. Oh, so kind of like a wave. And we can configure how fast it goes up and down, or how it goes up and down. Does it go quickly up, stay up, and then go down? Does it go smoothly up and down? Things like that. And that is controlled by the inputs of the wave around here. So the first one is the length, and that's how long is it takes for the value to repeat from to go up and down. We have the type of the wave, and this tells how this number is changing. Then we have the minimum and the maximum, which by default it's just going from 0 to 1. We can go into that soon, but another thing that the wave has that the LED didn't have is that it has an output. So it doesn't have only inputs. So what you do with outputs? Well, outputs can connect to inputs. So I can drag the output from the wave, and I can connect it to the input of the LED. So now these two structures are connected. And what it means, whenever the wave changes, it's going to change the value of out. And it's going to send that value into the input of the LED. So now this brain is controlling this output. So let's see what happens. Let's upload this.
What happens if you connect it to the place?
Then you would get like a behavior that is very undefined, because you're suddenly sending in different numbers to an input that expects different parts of the body, and it's just gonna go bananas.
Okay.
Like it's not gonna.
So don't do it.
It's not but I mean it's not gonna break or do anything else, but it's not gonna do anything meaningful, and that's very important in programming as well. I mean, because you can do whatever you want, but if you tell the machine to do something that makes no sense, then it makes no sense. And so, did everybody got that uploaded?
Yeah, it's flirting with us now.
Yeah. So now you have you have a visualization of what that wave does. So that's the value of the wave. It's waving between 0 and 1. And I just take 1 minute and mess around with the different, like maybe the length and the type. So how would you make it blink slower? Or how would you make it blink faster? What do you think?
With the length.
Yeah?
Interesting. Yeah.
So if I want to make it faster, do I make the length higher?
Oh, good question. Try.
Try. So I made it 5.3 now. Got it in. It's slower now. So what's happening here is that the length defines how long it takes for the wave to repeat its pattern.
Is that seconds?
Yes, and that's a value in seconds. So now it takes 5.3, 5.4 seconds for this to repeat. And if I would pick a smaller value than 1, it would be quicker. And you know, and that there you have it, like already a very basic activity to do. That is like explore this, and it can be like, it can be very rewarding for someone that never programmed, a bit like what you're doing right now, to just like fiddle around with these numbers and like, okay, now it's blinking really quickly. And another thing that you can change in here is the type of the wave. So right now it's a sine wave, which means it's smoothly changing from 1 to 0. That's why it's this very soft pulse. But I have different ones. This one I like very much is the ramp up. And I'm just going to upload it.
I think I saw one on your webpage. They made like a starfish that was really nice with different colors blinking.
Yeah, the blinking star. Yeah. Yeah, there is all those projects in there that you could access right now. So, okay, so now this is the ramp up. So do you have any idea how this is working? Like what is the type of blinking that is happening here is a little bit different. So it's
more of like it's increasing and then it suddenly drops. And then it's
exactly. So it goes all the way to 1, drops to 0, which is what this drawing here actually represents. Goes up and then down, and the other one is the other way around. It starts up and goes down slowly. So I mean, this is something to play around with. But okay, now we understand a basic brain connecting to a basic output. How do we build on top of this? Well, first thing to know is that one output can connect to multiple inputs. One input can only connect to one output. What does that mean? I could have another LED in here, and this one, I'm gonna put it on the right eye, and I could have the same wave connected to both of them. So now I have 2 LEDs being controlled by one wave. So now I have the 2 of them, moving together. And so now we're getting the gist of this type of programming that is called flow-based programming. And what is happening here is that we're not telling the Quirkbot to do things in terms of instructions. We're not telling it, do this, then do that, then do this. We're not telling, put the light on to the maximum, then wait a little bit, decrease the light. We don't think in instructions, but we think in relationships. So, we have this structure that controls the other structures. If one changes, the other one changes. Yeah, so you need to get to that mindset, which is a little different from Scratch, which is basically instructions in a visual mode. And the interesting thing with this is that it's a higher level way of thinking about programming, where you are more free to create a bit more complex structures. And this is like, how a lot of machine learning algorithms are going to be.
So this is more like asynchronous
Yes.
programming.
Yes, you don't think about time is not a variable. And this is how you're going to do like neural networks, is that sort of, so it's not like the most common way of programming, but it's also a very forward-thinking way of programming. And you can do a lot, because it's asynchronous, you can do a lot of things at the same time.
Yeah, right.
So now we have the LEDs being controlled. Okay, let's explore another output. So we've been playing earlier, we have the servo motor. So the servo motor looks just like the LED. It has two inputs. One is a place, so just like the LED, but now is a little bit different, the places. But with this backpack over here, we have number 1 and number 2. So if I wanted to connect the servo motor, I would select 1 or 2. Not the backpack, but the first ones. We're actually going to remove this. So I'm just going to select servo motor 1. And instead of light, we have position. And the servo can, but the same, it also goes from 0 to 1. In the real world, this corresponds to an angle. And this is actually not 180, this servo, this is 120 degrees that it can move. But when it comes to programming, we don't think about those degrees. We just think the start position, 0, the final position, 1. And because it's 0 to 1, I could use the same wave if I wanted to control that servo.
You can't adjust the speed with that. Then we come to that later.
Yes, let's get to that. So you mean have a different speed?
Yeah, because when we touched it, it changed the speed.
Yeah, I'll show you how we did that. Okay, that's number 2. No. Yeah, so now they are moving in sync with the eye. It's the same. Whenever the eye is brightest, is in one position. Whenever it's low, it's in a different one. Is your acting up?
I'm not sure.
Let's see what's happening. So you haven't connected it, but your LEDs are also not blinking.
Nice.
Okay, but that's you have a pulse wave. Got it. But now connect the wave to the motor.
Oh yeah. Is the code JavaScript or Java?
Nope. You mean when we switch to the text?
Yeah.
No, that's C++.
Oh, okay.
And this is actually Arduino. If you've done Arduino, and you can copy and paste this into Arduino. If you have the Quirkbot library installed, it will work. And you can just go in and type in this text and modify it from there. Though it's important, the text, if you modify the text and go back to visual, you're gonna overwrite. The text, it's secondary. The visual takes over, always over it. Okay, so now we have one brain connected to 3 outputs. We could change stuff around as well. So I'm gonna put the input now into this mix. So I'm gonna have the circuit touch. That was the one we were using earlier. And the circuit touch has a couple of properties into it. Again, it has a place. And the circuit touch can only relate to the arms and legs and the horn. So these are the only places available for it. So I'm gonna just select the horn, and it has a property called sensitivity that we can play around with it soon, but let's leave it at 0 now. And it has a minimum and a maximum, just like the wave also had a minimum and a maximum. And this, in the circuit touch, what does that mean? It means if I'm not touching the circuit, it's on the minimum, 0. The moment I touch the circuit, I activate it, it goes to the maximum, 1. So what I'm going to do here is I'm going to get the circuit touch, and I'm going to connect it to the servo motor. So if I just try to connect it here, it will take over that connection. So now I have a brain controlling these 2 outputs, and I have one input directly connected to this output. And let's upload this. Okay, so now eyes are blinking as usual. It's not moving. But if I come here and I touch, then it changed. So now this is the 1 position. If I let it go, it goes back to 0.
Wow.
Okay? So now we have something interactive in there. And the servo, you notice that it takes some time to get from 0 to 1. And that's actually the maximum speed that the servo can work. So this is not it doesn't move faster than this, which you might take in consideration when you build stuff. Okay? So now we have brains and outputs, inputs and outputs. I'm gonna show you one other brain here. That is the randomizer. That it's always fun. And randomizer, it outputs random numbers. These random numbers are gonna be in between 0 and 1, which means I can plug this to any input that I want to. And that's an interval in seconds in how often it's gonna spit out a random number. So I'm gonna leave it 0.5. And what I'm gonna do is I'm gonna connect the randomizer to the motor. And I'm gonna have the circuit touch connected to the LED. So we have 3 things going on here. The wave blinking one LED, the randomizer, or the circuit touch controlling the LED, and the randomizer controlling the motor. We upload that. This is the randomizer. I don't know what it's doing. It's just doing random stuff, which sometimes is just the sparkle you need to kind of breathe in some life into stuff and make a behavior that you cannot predict. And one LED is blinking with the wave, and the other one is attached to the circuit touch. Yeah, everybody on board with this? Cool. Okay, so let's remove a bunch of stuff here so we have some space. So now what I'm going to do is I'm going to do the thing we did before, that the servo was moving in a certain speed, but the moment I touched it, it moved in a different one. This is a little more advanced, so just bear with me here. So, okay, get rid of randomizer. I have a wave that I'm going to use to control the motor. And this wave has a length, right? 1 second. So what I'm going to do is, let's get rid of this too. I'm going to configure my circuit touch, but now I'm not going to output 0 and 1 from it. I'm going to output something else. And this thing that I'm going to output is the different lengths for the wave. So, okay, so we know that 1, yeah, is a 1 second. So maybe that's good enough for me. I'm just going to upload so I can see the speed that I want. So okay, this is 1 second. Okay, I'm happy with this. And now I'm going to define what is the faster version of this. Maybe 0.3. Oops. Can I upload this? Okay, I'm happy with 0.3. So now I know that 0.3 and 1 are the 2 different speeds I'm interested on. So what I'm going to do is I'm going to use those numbers as the minimum and maximum for my circuit touch. So my minimum is going to be 0.3 and my maximum is going to be 1. And I'm going to connect the circuit touch to the length, because any output can be connected to any input. So what does this mean? If I'm not touching the circuit touch, the output is the minimum. So I'm sending 0.3 in here, 0.3 into the length. So the motor is going to move fast if I'm not touching it. The moment I touch, it goes to maximum. This becomes 1. This becomes 1. Now it becomes slower. So let's see that in real life. So moving fast, the moment I touch it, it slows down. Okay? And, you know, once you start understanding this, that, you know, you can connect any input to any output, you can start making fairly complex things. You could connect, and this just as a curiosity, you don't have to, I could connect one wave to another wave. So I have this wave now that I'm going to have it very long. It's a 10-second wave. And the minimum of it is going to be 0.2. And the maximum of it is going to be 3. I'm going to make it even longer, 15. So what I'm doing here is a wave that takes 15 seconds to change from 0.3 till 0.2 to 3. And that's controlling the speed of the other way. So what's happening is that this is, maybe it's going to be harder to. Okay, let me give a more extreme example. So from 0, and I'm going to use a ramp up. Maybe 3 is too low. Okay, bear with me.
We're with you.
Should look now. Okay, I made something that I'm not following anymore. gonna make a shorter 10-second. This is not doing what I wanted to do. So what I wanted to do, I wanted to change this speed during time. So I wanted to start moving quicker and then go moving slower, and then move quicker and then moving slower. But I'm not getting the right values. And then we get into debug mode. Like, how do I go about this problem? Maybe I'm gonna have a sine wave. Maybe 0 is too much of a low number. I'm gonna start between this and 1. Maybe 5 seconds. Maybe there is a real bug going on here. Okay, this is not doing what I wanted to do. I don't have time to debug it. It's part of the process, and this is interesting.
That's programming for you.
Yeah, but this is it's good to, like, how do you get back up after something like that happened? Like, if you try something and something didn't work, and it's like, it's time to involve the students. Like, let's try to understand what's going on in here and delve into it. It's the important thing is just to keep the frustration outside, and don't let this bum out. But okay, let's have that wave controlling that, and I'm going to show you the last input that we didn't use it yet. That is the light sensor. Well, and I say last is the last of the simple ones. We have a lot more things once we hit the advanced filter, but we can leave that for another time. So the other sensor that we haven't played with is the light sensor. So the light sensor is the little black thingy that is on your box, and the way it connects, it's the same way as a LED connects to the arms and legs, and it also has a shorter leg and a longer one. So you do a little pinch, so it's a little bit tighter, and you slide it in the arms.
Is it okay to have a straw on as well?
Yes, it is. And I'm going to show you how we can use that to do something interesting. But now I'm just going to have it floating here, and I'm going to connect it directly into the servo motor. And I need to pick a place for it, and now it's in the right arm. So right arm, minimum mass, maximum, good to go. Turn on the Quirkbot, that's why it's not detected. So now, and I'm just gonna unplug it. We have, let's see if this is picking up. Servo motor 1 connected to the light sensor 1. Let me just get some light. No. What is happening? gonna connect it to a LED as well. Okay, it's something with the motor.
You want to borrow mine? Or?
Yes, strange behavior here. Let me just see if this. That was very strange. Okay, I think it was a glitch on the interface here. And you guys can try the same thing, so ignore it back up.
And mean this time is when there's light on it or there's no light.
Yeah, so as a light sensor, when there is no light, it goes to minimum. And when there is light, it goes to maximum. So now we have a very rudimentary light detector. So here it's a little bit darker, but if I go up, where's the sun? Try to catch. Okay, so this is the, now it's in front of the sun, out of the sun.
Oh, wow.
So it's,
You need to do it like all the time.
yeah, it's just measuring the light and sending that to the servo. So if I cover it, that's 0. If I let it go, it's 1. Or it doesn't ever get to 1 because there is a lot of light in the room. And remember the lightsaber thing I talked about earlier. So with this, you can do something like this. I can put the LED in here, and I'm gonna get this lightsaber and I'm gonna attach it to the, and now I have a light source in here.
Yeah.
That is directly shining into the sensor. And if I come and I squeeze the straw, I'm reducing the amount of light. And I mean, you can, oh, they came together. You can see that clearly. Okay, I didn't. No. Hey. You need, that's why it's good to remember to really squeeze the legs before you put them in, so they have enough friction. Nay. Okay.
Oh, there we go.
Yeah, so you can see the light in here, and when I squeeze it, I remove it. I don't know if you guys could see that.
Yeah. Yeah.
Yeah, I mean, you get the idea. I'm just reducing the amount of light. And with that, we can make like some sort of, oh, this is annoying me. Keep on. Sorry about that. Yeah, so with this, you could make some sort of pressure sensor, or you could like hide this underneath something, so when you step on it, it will squeeze this. Or you could use it because this also works, when you bend it, you also reduce the amount of light. So now I have, the robot copying the movement from a human-ish. So the light sensor unlocks a bunch of other options. So it's not, in the end, it's not only light that it's measuring. You can use it to sense other things if you're smart about how you prepare your lighting. Okay, so we've been through like the basics of the code interface. As anything else, if you want to learn this, you should experiment with this and kind of play around with it. By all means, switch to advanced mode and see what other things you have in there. As we pointed out earlier, we have a text mode that you can also see what these blocks that you did get represented in text. And this can be really nice to get kids to think about text in a different way, because there is no difference. This is the same, we had 2 nodes, and the output of this is connected to the position of this. When we switch to text, we have the light sensor, we have the motor, we have the configurations of the light sensor, and then we have the position of the motor connected to the out of the light sensor. It's the same thing, but if for some reason someone thinks this is easier than the other one, this is a very good opportunity to talk about, are you sure it's easier or you think it's easier? Or, there is usually this aesthetical block with visual code. Sorry, with text code. People get afraid of it before even knowing what's going on. So, if someone can this, they also can this. And it's good to reassure that. And, this can be a good way from this now. If you have like Arduino's workshop, you remember that. Well, now let's copy and paste that and move into that world. And I mean, we're not trying to build a closed ecosystem here. We're just trying to like remove the annoying parts into it, and then you can learn more. So okay, so we learned the basics. We learned the basics of what's in the box. We are running out of time. I don't know if you guys have a
Just
harsh. Yeah, everybody's hungry. Yeah, me too. So I'm just gonna wrap this up quick. So okay, we've done all these things, and I saved my program. So if I go back to my profile, it's there, and I can do whatever I want with it. And now I have this robot that works great for me, but nobody else cares about. So how do I get this back to a state there where I can start playing? Or how do I reset the Quirkbot to? And the quickest way to do that is to click on this little button here called Recovery Mode, and that's actually has some explanation of what to do when things go really wrong and the Quirkbot stops working. But on the bottom of this page, there is a button, Upload Factory Program, and if I press that, and I have a Quirkbot that is plugged in, and turn off. Yeah, now it's back on the program we started. So it's a good thing to do after a workshop. Last but not least, if you wanna think about things that you can do, on the Quirkbot website now, quirkbot.com, we have a few activities that you can make, and take this as inspiration. There is a lot of as I said, we're building this content platform so that we have more structured content coming. But you can use this as a start. Instagram Quirkbot account is also a good way to just see it being used out in the wild, and like you know, you can get into really fancy cars once you have continuous servos. And let's see if this is a video when I told you that you can control. Yeah, it's hard to understand what's going here, but it's like a little piano that is made out of the Quirkbot. And yeah, you should watch Therese Lindgren. She also has a nice session about the Quirkbot. A little workshop that she built a lot of stuff. And it's an activity that is nice to do. That is a robot race. So, I mean, if you just Google stuff around, there is stuff. And you should just think, like, just take that as inspiration. You know the basics now. And, you know, most of the Quirkbot company is in Gothenburg, but I'm here in Stockholm with my partner. So, I mean, I'm always happy to come and, like, discuss things and, you know, fire me an email and whatever. And, you know, I just had a list of, like, things just to say out loud, but, like, activities. You can do a lot of things with Strawbees only as well, you know, without involving the Quirkbot, but build big geometric structures or make a challenge who can build the biggest thing that doesn't fall apart and things like that. And when building the robots, you can have this approach like, can I make the quickest robot? Can I make the strongest robot? But also, can I make the cutest robot, or the one that is more afraid, or the one that loves people the most? Like, throw these emotional things into what you do as well. Build a bridge with Strawbees. Then could you use the Quirkbot to make that bridge smart and open and close when you get close to it? You know, like, use it to enhance engineering. Wearables is really fun. Like, do the hat, an extra body part. We do this workshop that is the catwalk that we actually need to do like a little outfit, and then we get all the kids to actually walk on a catwalk and, you know, show their outfits. Yeah, music instruments and controllers, since you can use the Quirkbot to do things on the computer. So it's quite a lot that can be done, but it requires like an open-minded thinking about how to build an activity, because it is very open-ended. And, you know, the goals of the activities is up to you guys, like what you really want to get out of the learning. What this gives you is just a framework that is fun. It's fun, and it doesn't hide stuff away. It's sensors and motors and programming, but just in a context that it's fun. With no more to it, thank you for listening to me. And hopefully this was recorded. Yay. Okay, everybody say hi, because it was only my face. Okay, and we can access this video